is centroid in the centroid theorem. Now, the centroid actually wasn't the circumcenter that I showed you all yesterday with the balancing point. It's actually the centroid. The centroid is the balancing point of a triangle. Now, the centroid is three lines that connect from the midpoint to the opposite vertice. And the centroid's the point where they meet. So when we create three lines connecting the midpoint of one side to the angle opposite it, and where all three of these lines intersect is called the centroid. Now the centroid has an interesting property to it. Let's see the expo marker. In that the entire length of the line is equal to, well, let's say it the other way around. The bigger part of the line from the centroid to the angle is 2/3 of the entire line. So the bigger part of the line is 2/3 of the whole. And the smaller part of the line is 1/3 of the whole. So when we look at this figure here, we say that AP is equal to 2/3 of AE. AP is 2/3 of AE, the entire line. Well, we can also say that PE is 1/3 of AE, because the shorter part is 1/3 of the whole. And we can do that the same for the rest of them. We can say that DP is equal to 1/3 of DC. And lastly, we can say that FP is 1/3 of BF. So really what we're saying is that the bigger segment is equal to 2/3 of the whole. And our smaller segment is equal to 1/3 of the whole. Any questions on this so far? Erase all this here. Now there is something interesting with the smaller part. We go from here to here. Try to line this up a little better. So that there is from F to P, yes? Okay. Let's see where it's at. Infinite cloner. Now if I take that and place it here, how many of the smaller make up the bigger one? 2. So what we could also say is that the bigger section is equal to twice the smaller section. Or vice versa, that the smaller section is what? Because if the bigger is twice the smaller is half of the bigger. So our bigger section is 2/3 of the whole. Our smaller section is 1/3 of the whole. And then we can say that the bigger section is equal to twice the smaller, or the smaller section is equal to half of the bigger section. And this will work for any centroid. Any questions on this here? So let's look at our first example. In RST, point Q is the centroid, and SQ is 8. Find QW and SW. Exactly, because SQ is the bigger section. The smaller is equal to half of the bigger, so the smaller section would be 4. It would be 12. Because how can we go about finding that? Exactly. All right, we can add SQ and VW to get 12. We don't have to use the 1/3 and 2/3 to find it, because if I know the two parts, we can get the whole. Why don't we go on and find the other lengths, because they did give it to us. Because they told us RQ is 10. So what's QV going to be? 5. And RV is 15. And let's do the last one because they told us QT is 12. So QU is, and UT is 18. And that's it. Because we found all the lengths. So in this one here, we're going to find RQ and RV, as well as SQ, SW, and UQ and UT. We're going to find them all. So let's start off with RQ and RV. 10, because the bigger is equal to twice the smaller. The bigger is equal to twice the smaller. The smaller is equal to half of the bigger. So this here is 10, and RV, the whole length is 15. What would SQ be? And SW would be? What would QU be? And UT would be 15. Now the bigger side is always going to be going from the centroid to the angle. The smaller side will always be going from the centroid to the side length. Any other questions on this here before we look at the next one? If BD and CF are medians of triangle ABC and CE is 17, what is EF? So point E is a centroid. So they told us CE is so EF would equal half times 17. Yes. What would FC be? Yes. Is we're going to take 8.5 and add to it 17, which would be 25.5. Any questions on this here? In the triangle, these two are medians, so U is a centroid, and they tell us UP is 7.3. Find RU. Right, because we're doubling 7.3, we're multiplying it by 2, which would be 14.6. Now RP would be, because we would take 14.6 and add to it 7.3. 3 and 6 would give us 9. 7 and 4 would be 1. Carry the 1. So it would be 21.9. Any questions on this here? If EM is 2x plus 3 and MG is x plus 5, what is x? So let's see here. So MG is x plus 5. EM is, and we know that point O is a centroid. Now to create these centroids, what are we connecting? The medians. And a median does what? It connects the angle to the middle of the other side. So that means these two lines are congruent. So to find the value of x, we can really just set these two equal to each other and solve for the value of x. Two x minus x is going to be x plus 3 is equal to 5. And then we would subtract 3. X is equal to 2. It didn't ask for, but what would be the length of each of these lines? 7 and Any questions on any of this here? RU, SV, and TW are medians of triangle RST. What is the measure of RW? If RV is 4x plus 3, VT is 2x plus 9, and WS is 5x minus 1. Well, what do we need to do? We need to solve for the value of x and plug it back in. So we could say that 2x plus 9 is equal to what? 4x plus 3. Because these two line segments are congruent, and these two are, but we can't say that the 5x minus 1 is congruent or equal to the 2x plus 9 or the 4x plus 3. But we will say that the value of x will be the same. So what can we do first? We can subtract 2x from both sides, which will tell us 9 is equal to. And subtract 3 from both sides, which will tell us that 2x is equal to. And then we would divide by 2. Exactly. And x is equal to 3. Now to find the desired length, what do we need to do? Plug it back into 5x minus 1. Because we'd have 5 times 3 minus 1. 5 times 3 is 15, and 15 minus 1 is. So WS is 14. Any questions on any of this here? Any question on anything we've done so far? WS, so RW is 14 as well. Because it's a median, they're going to connect to the midpoint. So these, each side of that line on either side of W would be the exact same. The same thing is true over here. Any questions on any of this here? Now, the altitude of a triangle is the perpendicular segment from the vertex to the opposite side. Now, the altitude of a triangle is not always going to be contained inside the triangle, because if it is an obtuse triangle, the altitude may be outside the triangle. The height of it can be outside, or it could be inside. Any questions on this here? And where these altitudes meet is called the orthocenter. Where the altitudes meet is called the orthocenter. So the lines containing the altitude of a triangle are concurrent. This point of concurrency is the orthocenter of a triangle. The lines containing AF, BD, CE meet at the orthocenter of G. Now, the orthocenter for an acute triangle, if all angles are acute, will be inside the triangle. Now, the orthocenter of a right triangle will actually be on the triangle itself. And for an obtuse triangle, the orthocenter is actually outside the triangle. It's not contained in the triangle. But there's not any real properties with the orthocenter that we have. Any questions on any of this here? Okay. Any questions on anything we've done today? That's it.